In the name of God, the compassionate, this is the last session on C++ TMP, template metaprogramming. So I would just tie up some loose ends from the previous sessions, and pretty much that would be it. I won't be surprised if this session is not as long as usual. So I'll go through my list of topics that I thought I should present here, because the previous time I didn't take note, and unfortunately I messed up. So thank you for the confirming nod, Jan, when I said I messed up.
That was just I was doing something else. I'm sorry.
Oh, that was quite interesting.
I'm sorry.
Okay, now let me see. So what do I need to share with you? Oh, come on. Right. So, unfortunately, Daniel is not here today, and he will not be here. But this is in continuation to his question. So he had asked me a few weeks ago, why do we choose to sometimes go for const expert ifs like this one on line 268 inside the body of a function, and sometimes we just go for different overloads. And I tried twice to respond to that question. The previous time I was going to the right direction, but unfortunately at a very important point, I just lost my train of thoughts, and I got completely derailed. So this is me for the third time trying to answer that question. I hope that this time I can do it. Now, so once upon a time, there was an occasion in the recordings, also available, when Niels was trying to implement this function. And so he had 3 overloads, or maybe 2 overloads for when n is 0. Right, was it? No. So let's say, right, he realized that he couldn't, but he was going towards that. Let's say that we want to take this if out, right, and produce another overload, right? So if we really want to do that, especially because there are no there's no partial template specializations for function templates in C++, right? The way to do that would have been that you do, well, why don't I just copy paste what's here? Now my editor is for some reason quite slow. Oh, why? Right, it would be checking for n being 0. So yes, we don't have partial template specialization for functions, but you can trick it this way by instructing the compiler to get rid of the inappropriate overloads at the overload resolution time, right? Now, so then you would do turn out, right? Now let's say that I do this for the roads. Now, can anyone now guess what would go wrong?
Mm. It wouldn't know which overload to choose if n is 0.
Well, it does know which overload to choose when n is 0.
Oh.
But you're on the right track. There is something extra. So you see, there are two conditions here. Oh, by the way, if I'm about to do so, then this else is also extraneous. So try to construct a conflict between these two overloads. The first two overloads.
Oh yeah. If the list is empty, n is 0.
Yes.
Yeah.
Right. So the point is that overload resolution takes place according to best match policy. Whereas in the if statement, there is a notion of directionality involved. The condition that comes before the if statement that comes before grabs the attention first, right? So this one, if there is a conflict between, well, if we pass an empty list and n is 0, the empty list will go into here because this is a better match, right? And so it will not come to here. This one is chosen when list is not empty, but n is 0. So we have kind of separated the two. Now we could have, and this is where I got off track last time. So we could have done, instead of having the first overload, so we could have done this one. Let's see. I'm not sure why my editor is so slow today. We could have done we could have done this and it would have worked, because now we no longer allow the compiler to go for its best fit, best match policy. We are kind of, we have given it an order. I had my first yawn from James. Yeah. Now, so this is previous time. The previous, by the way, this has to be an else if we want to do that. So the previous time when we were talking about it, and I was responding to Daniel, I said, if we want to remove the first overload, which is now commented, then this is what we should do. That's correct. But it's not because of this that we, we wanted to get rid of the other overload. It's because if we had the two overloads that are currently commented together, we would have been trapped by the condition when both n is 0 and the list is empty. Right? So that's that. Now, thanks God I didn't mess up come on, with the explanation this time. So let me just uncomment. We'll delete this one and right. So that's point number one. Right. The other one is that The book speaks at some point about delta functions and their interaction with templates. I don't really know off the top of my head how much of that is in the chapters that I taught you. So I'm going to give you an example. We have already seen lambdas. Did I say delta? Lambdas, anyway, lambda functions. We have already seen a good bunch of them. Now, but we haven't seen capturing. So now I'm going to show you capturing. Let's first of all go to here. Is this vect? Okay, yes, it is vect. Now let's go to blah, 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 blah. Right. So, come. Here's the implementation of fold L in Idris. Right. So as you can see, fold L in Idris is implemented in terms of a generalization of it, which is called, oh, this is fold R, by the way, sorry, fold R is implemented using a generalization of it called fold R impl, which in addition to the usual folding apparatus also takes an extra function called, well, referred to here as go, and the idea is that every time that you want to perform one folding, you also on the top apply one instance of go to the result of f of x, right? Now, and then, so what it does is that, okay, fold R is a special case of that, because then the go function that you would pass is ID, which is lambda xx, right? Now, if we can also take a look into the type of this, right? So, or where it comes from. And let me see, I got, was I here? Let me see. How do I go back? Okay. Right. So suppose that we wanted to implement fold R in this fashion, right, which is we would want to have a fold R import and then do fold R as the ID passed for go. I'm not asking you to do that now, because I would like to teach you the capturing. But I'm going to show you my solution for that. But maybe we should go for a joke in the meantime. Now let's see. James, are you confused? You had a strange look. Okay, good. Let's see. Mikhail, could you please give us your joke?
Oh, I had one, but I forgot.
Okay, we'll just move on in the sake of time, in the interest of time. Jan, would you mind? Jan, are you there?
Oh yeah, I'm here.
Okay, you're thinking.
I have a joke for today. Oh.
Okay, you told us something before, so that in the last session, but James didn't. So let's go for James. James, you go.
Oh,
Oh, come on, guys. You don't
Wait,
seem very
I've got-
prepared for jokes.
I've got a lot to choose from. I'm just
Okay.
thinking about the most appropriate. That's
Okay.
the
The challenge. Okay.
fine, we'll go for this one. Why don't scientists trust atoms?
Mm.
Because they make up everything.
Mhm.
Yes, that was a good one. That was a good one.
I've got
Right.
a lot where that came from.
What was it, sorry?
I've got a lot where that came from.
Uh-huh.
Too
Sure.
too many jokes to choose from now.
Right. Okay. Good, good, because I'm gonna pick up on you another time. Right. Let's see. So let's go to the C++ counterpart for this. Let's see. So that was Poldar import, and again my editor is very slow for some reason. Right. So the first thing to notice is that the excess of syntactic noise, right? You see this entire block. So see that this block of massive code is the equivalent of these, right? So my apologies for all that syntactic noise. Now, so as usual, we have like this is more or less the case about all of our implementations of the address functions equivalents. So we have for each pattern match, we have one overload, right? So for this one, we have the one above. So let me just maybe comment it that way, so that you can probably relate to it better. Now, part of the mess that you see here, and probably a big part of it, is the require statements, because we can't do the beautiful, type signature that you get here, right? And I should remind you that we can only enforce this much of it, right? It's with the autos, by the way, because this is not a dependently typed type. We can, in this very occasion, also enforce that one. But if it would have been that we wanted to do, we wanted to receive a vector of a specific size of a specific type, we could have not enforced at least the size of it. Right? Now, so this part, the requires part, which is not quite the focus of me here, but you should be able to understand it, is trying to, is trying to enforce how much of that is it enforcing? Okay, it's about go. It's saying that go is of this type. So, this type. Right, this is this part. Okay. Likewise, is this. Bless you. Now, the other thing is that, so we don't do anything with F here. So I don't put any kind of constraints for F in, but F has to be applicable to all the elements of the list. And so, the real mess that you see over there is to ensure these two lines. Where do I put that? Is to ensure this, right? Okay. Now, can everyone understand the lines that I just commented? Yeah. Okay. Now, the new part are these two lines, the implementations. Now, the implementation of the one in the top is relatively obvious. I would guess that you do get that this is this. Right. The less obvious one is this one. Right now, so what you can already understand is perhaps that okay, we have a folder import. We are passing F and E as the first two arguments, and we are passing the tail of L. We could have just written list of X's and then pair around braces, but that I just didn't fancy that, so I didn't do that. Now, these parts I'm sure you do understand. The other part that you do understand, I hope already, is that we are doing a lambda here. And this is our lambda. Now let me just break this line into several. And this bit is meant to be this. Right? Now, in the absence of function composition for lambdas, right, we need to produce a new lambda, which is not eta reduced, right? So, which does what? Which says that, okay, I will take a y and then apply f of x and y and then go on the top, as this guy is doing, right? Now, so that part is obvious. The new part is these two that come in within the square brackets. What this is saying is that go and f, which I use inside the body of the lambda, come from outside. Well, where do they come from? They come from up here, right? But what matters is that they come from outside this lambda, and I would like to capture them. Right? Now, these being things which you capture, and you speak about the type. Well, you speak about the capturing of which. You can also do all sorts of things that you do normally with arguments. So, for example, you can with parameter types. So, for example, you can say that I want to take this as a reference, which would then prevent it from being copied. Or you can say that I want to do a constant reference, or you would say that I would like to do this as an R value reference. Oh, by the way, I watched the recording of the previous session, and I realized that on one occasion I said L value reference when I meant R value reference. So this is an R value reference, not an L value reference. Now anyway, so now what that means is off topic here, but if you go to CPP reference, I already have the page, and look for value categories, you would be able to see R value, right? R value references, but and that will tell you that the term R value reference is a bit old-fashioned nowadays, but it does have its own category. Anyway, now the idea is that we can do pretty much all the kinds of value categories that we can do with function parameters here. Now, there is also something like, we could have done this to mean that we'll capture everything that comes outside, right? Now, if we do this, it means that we're not capturing anything. There is no, this is a closed term in terms of, lambda calculus, you would consider that a closed term. Whereas if you do it like this, it means that it's I don't know, do we have such an equivalent in lambda calculus, like a
Yeah, it would be just everything that it's embedded in
yeah,
the large lambda.
yeah. Right. Yeah, okay.
You have like
Yeah.
lambda.
So the set of the free variables here is the set of the variables. Yeah,
pretty much.
okay. Was everyone able to follow what I explained? Yeah. So let me see. Let me go back to where it was and go back to the unreadable status that they were in. I have to say that I don't like to teach bad coding, and this is very much stylistic of me to choose to do them like this. I hate short lines when the thing is pretty obvious. Now, I'm sure that if someone doesn't have the equivalent address or the equivalent Haskell in mind, navigating through this line is quite difficult. So the vast majority of the C++ programmers would find this horrible, which means that if in the industry you don't have the pleasure of being the only one who touches their own code, which is a very rare pleasure. I did have it once. So I used to work in the gaming industry for 2 years, and so I was the extreme backend developer. Because my code was deep into template and macro metaprogramming, no one in the code other than me could touch them. And so I had the pleasure of being the only one who would mess around with my code. The other people were only just my users, and so I could simply follow my own styles, but if you do have other teammates who would read into your code, then you shouldn't do what I just did. Now, so okay, that's another tick in my list. Any questions thus far? No. This is a good time for another joke. So let's see. Jan, did you manage to extract anything? Okay, go on.
So the student walks into the canteen, and he says to the lady, 2 sausages, and everybody around hushes and sort of looks at him and continues, and 17 forks. So there's a Soviet joke back in the day.
I don't get it.
Well, because the student ordered 2 sausages, the people were very, you know, impressed by this
Yeah.
kind of wealth. But then, of course, saying 17 forks because he's going to share it with 16 of his friends.
That's yeah.
like
Reminds me of
joke.
yeah, reminds me of something that had happened when I was in Edinburgh to the Scottish social party. I wouldn't go online about it, but it's you should look that up. Yeah. Right. The next topic is about these. So let's say I go to test this. Right. So as of an occasion when I wanted to zip to two lists with a function, I want to, well, in my tests, I wanted to perform a plus on them, right? So I take it that everyone here can understand this line, right? Mikhail, are you following?
Yeah. Yeah.
Okay. Now, so it's, you know, if it would have been Haskell or any sensible functional programming language, you should have been able to do, instead of this huge mess, you should have been able to do this, right? Instead of this. Maybe I should do something else. Oops. Oh, cool. What does it do? Okay. I should do it like this. Right. So this is all we wanted. We just wanted to pass a plus. And I told you that you know, there is no such thing in C++. You know, there's no eta reduction. And therefore there's no, you can't just pass the operator as the operand to as a lambda that you would want to pass to another function. Now, there is, however, a library of things like plus for a very limited number of cases. So there is, let's see, there is a function object, and you now know about function objects because I taught you that in the last session. That has an operator, a call operator, this one, sorry, which simply performs, you know, the addition. Right now, these things exist in a header called functional that has a few, not many, you know, function objects. So it's very basic, you know, plus, minus, multipliers, divides, modules for mod, and negates for the unary minus. You also have some comparatives, but you know, it's not really a handful. It's not that handful, no. Now, you know, in Haskell, you would have had the possibility, so not within zip, but let's say that with another function, you could have just did things like this, 3 plus as you just binding one of the operands, right? Now the zip with expects a binary operation, so that wouldn't type check in Haskell either for zip with, because this would then produce a unary function. But anyway, there are things in functional also for binding, right? So there's another header called there's another part of the header functional called bind, right? Where you can right, you can do things like I don't know, bind front, bind back, or you can do things like bind with placeholders with these guys. Underline 1 is the first operand, underline 2 is the second operand, and so on and so forth. But to be perfectly honest with you, the notation is so heavy. I would, you can do things like this if you really want to. So the equivalent for this one is like bind plus and this, right? I'm not sure whether I would want to choose this one instead of the lambda. It's just, I mean, I'm not now. So that's that. But I have to tell you that bind and bind first and all that, they have quite a number of caveats. And I'm going to list a number of them for you. First of all, even though there is a function object called plus, I still can't pass the plus sign here. Right, so no ops, no operators. That's the first drawback. The other one is that so bind front can work with functions that of all sorts of arities. What it cannot work with is variadic functions. So if you have a variadic function and you want to do the bind front, then you can't do it. But if you have a function of a high arity, a fixed arity that you want to pass, oops, someone's coming in. If you want to have a fixed arity of sorry, just a moment. I'm going to pause the recording. Okay, so back to the recording. I was saying that bind cannot deal with variadic functions. I had already told you that bind cannot accept operators. The other thing is that bind cannot deal with auto parameters, and this one really hurts. If I had if I wanted to bind this lambda expression, I would have not been able to, because this lambda expression takes auto type parameters, right? The other is that right, I could have also, instead of bind plus and one, done bind bond or plus. If I wanted to. Yeah. So that's pretty much what I wanted to tell you. Now, I think that should be it. We can, if you don't have strong objections, we should perhaps end the session here.